Hello class, and welcome to the Unit 5 review part 1. And here we want to determine the mean of the sampling distribution of the sample mean, the standard deviation of the sampling distribution of the sample mean, the mean of the sampling distribution of the sample proportion, and the standard deviation of the sampling distribution of the sample proportion from the given parameters. The population means 36, population standard deviations 8, the sample size is 100, the population size is 17,000, and the probability of success is 0.7. We want to round the answers to the nearest thousandth when appropriate. So the mean of the sampling distribution, the mean of the sampling distribution of the sample mean, that should just be the population mean, so 36. The standard deviation of the sampling distribution of the sample mean will be the population standard deviation 8 divided by the square root of the sample size of 100. So that's 8/10, which both reduces and rounds to exactly 0.8. Then the mean of the sampling distribution of the sample proportion, this should just be the population proportion, which is 0.7. And then the standard deviation of the sampling distribution of the sample proportion is the square root of, this would be 0.7 times 1 minus 0.7, or 0.3, divided by 100. This gives us about 0.046 in this case. The second question is, suppose a population has a mean of 7 for some characteristic of interest and a standard deviation of 9.6. A sample is drawn from this population of size 64. We want to know the standard error of the mean. So I know the name for that was the sampling distribution, the standard deviation of the sampling distribution of the sample mean. So that'll be, and presuming this points me to right, of course. There we go. This is the standard deviation of the sampling distribution of the sample mean. This will be 9.6 divided by the square root of 64. So 9.6 divided by 8, this should be 1.2 as the standard error for this case. Question number 3. Average score for all golfers of a course has a mean of 72 and a standard deviation of 4. Suppose 64 golfers played the course today. We want to find the probability that the average score of the 64 golfers exceeds 73, rounded to 4 decimal places. So we have a sample size here of 64, right? So that'll be fine for this, for us to call this distribution approximately normal. The mean of the sampling distribution of the sample mean will just be 72. The standard deviation of the sampling distribution of the sample mean will be 4 divided by the square root of 64, also known as 4/8, or 1/2, or 0.5. And for this, let me sketch a normal distribution for this. So mean is 72. The value here that we want is the probability that this average exceeds 73. So 73, this is going to be now with a standard deviation of 1/2, be 2 standard deviations away. So kind of a big difference for this case. But to do this, we are going to go to our same spot we have been going to for a bit now in StatCrunch. With that being open, we are going to go to Stat, Calculators, and then Normal. Our mean is going to be, for this case, 72. The standard deviation for this particular problem will be 0.5. Now the probability our sample mean is greater than 73. And we could see from this that we are going to get a decimal of about 0.0228 in this case. So just to write that in our problem here, this would be 0.0228 in this case. Question number 4. We have assumed that blood pressure readings are normally distributed with a mean of 115, a standard deviation of 4.8. If 36 people are randomly selected, find the probability that the mean blood pressure will be less than 117, rounded to 4 decimal places. We know the population is normal, but sample size is also 36. So this is going to be the approximately normal again. The mean of the sampling distribution of the sample mean is going to be 115. The standard deviation, the sampling distribution of the sample mean, will be 4.8 divided by the square root of 36, also known as 4.8 divided by 6. This will give us 0.8. This particular graph looks something like this. The mean of 115 is here. And here we want the probability x bar is less than 117. So based on this standard deviation, this would be more than 2. So let's say about right here. And we are referencing the area below that. Actually, this graph is going to be a little bit off, but that's okay. This big full graph. So this particular calculation, instead of StatCrunch, it's going to change the mean to be 115. Standard deviation of 0.8. And we want this less than 117. This will give us a probability of about 0.9938 in this case. 0.9938. Number 5, according to the law of Number 5, according to the law of large numbers, as more observations are added to the sample, the difference between the sample mean and the population mean, this will tends to become smaller. And that's due to the fact that as that sample size there increases, what that means then is that that's the standard error is going to start shrinking the more and more samples that we have, which then will then cause our probabilities to then be impacted by that as well. Question number 6. There's a couple of parts to it. According to a survey in a country, 29% of adults do not have any credit cards, excuse me. Suppose a simple random sample of 500 adults is obtained. We want to describe the sampling distribution of the sample proportion of adults who do not have a credit card. This will be, well, we first need to do our check. n times p times 1 minus p. This is 500 times the 29%, so 0.29, times 1 minus 0.29, 0.71. This product is about 102.95, which will much greater than 10. So this means that shape is approximately normal. The mean of the sampling distribution of the sample proportion will be 0.29. And the standard deviation of the sampling distribution of the sample proportion is going to be the square root of 0.29 times 0.71 divided by 500. This is about 0.0203. And we want to know, is it unusual if a random sample results in 165 or more and having no credit cards? So the value of p hat is going to be 165 out of 500. And this is about 0.33. So, pictorial representation. The mean of 0.29 will be here. And based on that standard deviation, 0.33 is going to be pretty much down here. And we want this area above it. So this is the probability we have a sample proportion greater than 0.33. And we need to toss this into StatCrunch to give us this particular probability. So the mean was 0.29. The standard deviation was 0.0203. This will be a greater than 0.33. And doing so gives us a very small probability here, right? 0.0244. So 0.0244. And let's face it, that's less than 5%. So yes, this is unusual. Okay, so moving right along. Now question number 7. This one being, suppose a geyser has a mean time between eruptions of 62 minutes. We want to let the interval of time between the eruptions be normally distributed with a standard deviation of 23 minutes. We want the probability that a randomly selected time interval between eruptions is no longer than 105 minutes. So because we're told that this is normally distributed, we're fine with this problem. But this one wants to know about a randomly selected time interval. There's no sample size here. So because of that, we're going to do this in the normal way. This will have a mean of 62, as set up in here. Standard deviation of 23, which again, we were told. A pictorial representation of this looks something like this. Mean is 62. We want the probability that the mean time between eruptions is no longer than 105 minutes. So the mean time between eruptions is longer than 105 minutes. So this would be the probability x is greater than 105, mean of 62 here. 105 will be down near this tail. And we want the area above it. So tossing that into StatCrunch. This will be the mean of 62. 62. There we go. Standard deviation of 23. This will be greater than 105. This gives us a probability of about 0.0308. Which makes sense for that. For part B, this is the probability of random sample of 7 time intervals between eruptions has a mean longer than 105 minutes. So this one gives us a sample size of 7 of these time intervals. And notice how this makes note of the mean. Right, this one up here did not mention the mean at all. So the mean for this sampling distribution of the sample mean will still be 62. Standard deviation, though, of the sampling distribution of the sample mean will be, and let me make sure I write this correctly, 23 divided by the square root of 7. That's about 4.904. So this probability, just to point out, the one in the test is not going to be this small. But here's 62. 105 will be, oh boy, pretty down this area. And let's just say, doing this is our probability that x bar is greater than 105. So let us see what happens. So the only thing we need to change on this problem is this standard deviation needs to be 8 point. Oh, excuse me, I wrote the wrong number before. This would be 8.6932. I'll update on the page in 1 second. This gives us a very small decimal. That's 0.00000038. That's a total of 1, 2, 3, 4. Total of 6 zeros in front of it. So one of the tests is not going to be that small. Let me just very quickly update this standard deviation as I wrote the wrong one. This is 8.6932. Let me fix that 3. Okay. So 0.00000038. So already a pretty small number. And part C is actually the same exact thing. Only this one wants a random sample of 22 time interval eruptions, has a mean time longer than 105 minutes. So mean is 62. Standard deviation of the sampling distribution of the sample mean will be 23 divided by the square root of 22. That one is about 4.904. So if we thought this one was small, well, this one will be even smaller. 62 is here, 105 is practically on the edge of this tail. We want the area above it, whatever that means. So the probability x bar is greater than 105. So once again, we need to update that standard deviation in StatCrunch. Let's do that. 4.904. This gives us so small of a standard deviation. Doesn't even want to round it for us. So because of that, this gives us a probability that's effectively 0. Again, the one on the test is not going to be that small of a number. At least not that small where it's going to give you 0. What effect does increasing the sample size have on the probability? Well, we can see what happens. It decreases it. So for this particular problem, this is going to be if the population mean is less than 105 minutes. Then the probability that the sample mean of the time between eruptions is greater than 105 minutes. Decreases. Because the variability in the sample mean decreases. As the sample size increases, which I will not have enough room to write. As the, I'll write it here. As the sample size increases. And then part E, what might you conclude if a random sample of 33 time intervals between eruptions has a mean longer than 105 minutes? So for this, we don't even necessarily need to be going around calculating this particular value. What we would conclude for this is the population mean is 62. And this is just a row sampling. This would be one of the answer choices you would select. There's also a second one, this one being the population mean may be greater than 62. And why is that? That's because of the sample size being 33 here. All right, question number 8. To assess attitudes towards issues that affect the results of a village, the village randomly chose 100 families to participate in a survey of life attitudes. The village received 618 completed surveys. Where is the sample proportion of completed surveys? P hat. This will be 618 divided by 800. As a decimal, that will be 0.7725. Okay, that is part 1 of this Unit 5 review. And I will see you in the second part of this review. Thank you.